Alrighty, Mr. K is going to be in Thailand, so here's your first video on Polar. This is going to be a review of Pre-Calc Polar, which last semester, if you took Pre-Calc with me, we didn't do. I'm sorry. It's going to be okay, though. So far, in our math career, we have only talked about rectangular coordinates, aka x comma y, aka the Cartesian coordinates. Well, today we're going to learn another system called the polar coordinate system. Yay.
Yay.
Yay. So we're going to choose a point in the plane and we're going to call it a pole and label it O, or the origin. From O, we are going to construct an initial ray called the polar axis. So this right here. And then each point P in the plane is assigned the polar coordinate r comma theta. So if I were to move up using my theta here, r comma theta is going to be a point. R is the directed distance from O to P. So my distance here. And then theta is going to be the counterclockwise directed angle formed by the polar axis in OP. So here is theta in its counterclockwise direction. So kind of similar to the unit circle. When r is negative, we graph the point r comma theta plus pi. So here, if r is negative, then of course, if I'm going to add pi to that, then I'm just going to have the negative counterpart right here. So we're just going to move it the opposite direction. And because a complete counterclockwise rotation is given by the angle 2 pi, r comma theta can be represented by r comma theta plus 2 pi n, right here, or a negative r plus theta plus 2 pi, 2n plus 1 times pi. Usually what I like to do is just look at the polar coordinate and then find my representation there. I don't like memorizing this because I think this is too much for me to memorize. But, you know, that's just my opinion. All right, so number one, we want to plot the following points. So for A, I want to plot 1 comma 5 pi over 4 in my polar coordinate system. So the first thing that I'm going to do is go to the right one. But first think about my origin. So this is my little origin. I'm going to go right 1 unit, which is this right here. Then I'm going to go a counterclockwise rotation to 5 pi over 4. In this case, it's going to be right here. So this point right here in green is going to be A. So that represents 1 comma 5 pi over 4. B says 2 comma 3 pi, so I'm going to go to the right 2 units, brings me right here. And then since it's 3 pi, I'm going to do 1 full rotation to get 2 pi. And then I'm going to do another pi. That gives me this right here. So this right here is going to give me 2 comma 3 pi. So I went 2 pi, then another pi to get to this right here. Oops. Now, of course, you could use coterminal angles for part B, because if I were to subtract 2 pi, I'm going to get pi right here. Kind of makes sense, hopefully. For part C, I'm going to do 2 comma negative 2 pi over 3. Since this is negative, I'm going to do the clockwise rotation here. So I'm going to start at 2. Then I'm going to move 2 pi over 3 in the negative direction. If I'm going to think about 2 pi over 3 in the negative direction, that's going to be, let's see, 6 pi over 3. And then minus 2 pi over 3. That's going to give me 4 pi over 3 right here. That's how I move. Of course, once again, I can find my coterminal angle right here. My coterminal angle would be 4 pi over 3 if I were to add 2 pi here. So that was part C. Part D, I'm going to have negative 3 comma 3 pi over 4. What I'm going to do first is just go right 3. So 1, 2, 3. And then go to 3 pi over 4 right here. Now, because it's negative, I'm going to do a 180 rotation, and that's going to give me this point right here at 7 pi over 4. So this right here is going to, this right here is going to be my final answer for negative 3 comma 3 pi over 4. All right, now we have different representations as you saw from part A, B, C, and D. So here for number 2, let's go ahead and try and write 1 comma pi over 4 3 different ways using 3 different representations in terms of my polar graph right here. So we know that 1 comma 5 pi over 4 is this thing right here. Notice how here this was a counterclockwise rotation. Well, what if I used a clockwise rotation for 1 comma 5 pi over 4? That's going to be, let's see, let's use a different color. Let's use pink. So that's going to be this from this right here. What's my distance from 0 to negative pi over 4? Like I said, negative pi over 4. So this right here, I can rewrite this to be 1 comma negative pi over 4. Okay. Now, another way that I could do this is think about my negative 1. If I had a negative 1 right here, then this means that I'm going to be rotating 180 degrees. So if this was right here, then I could say that I have pi over 4 right here. So I could also say negative 1 comma pi over 4, because if I did that, then I'm going to go to pi over 4. Then I'm going to rotate myself 180 degrees to get 5 pi over 4. So that's another representation. Then, of course, another representation would just be doing coterminal angles. So I could do 1 and then 13 pi over 4, like I did with part B here, where we did 1 full rotation and then back. So here, if I did 1 full rotation, that's going to be 8 pi over 4. And then to get 13 pi over 4, I'm just going to add 5 more right there. Crazy. All right, number 3 and number 4 are very similar, where you're just going to write the point 3 different ways. What I'm going to encourage you to do for 3 and 4 is to plot that on number 1 here, so that you could see what's happening with 3 and 4. All right, for number 5, we have a little right triangle right here, where we have my pole and then my rays. All right, so once again, I have r comma theta right here, and I want to connect this to rectangular coordinates, or in this case, Cartesian coordinates, are the same thing. If I were to think about basic right triangle trick for cosine, sine, and tangent, cosine would just be adjacent over hypotenuse. So that's just going to be x over r. Sine would just be opposite over hypotenuse, which is just going to be y over r. Then tangent is just y over x. Well, if I want to find my rectangular coordinates xy, well, I'm just going to multiply r to get r comma cosine, r cosine theta. Y is going to be r sine of theta. And then to find r square, I'm just going to square this, and I'm going to square this. And the reason why is because remember that sine square of theta plus cosine square of theta is going to give us 1. So that's just going to be me left with r square. So that's me saying x square plus y square. Now, why is this important? Well, sometimes we are given a coordinate from, let's say, polar to rectangular, and we want to convert it to that, or we want to convert it from rectangular to polar. So like number 6 right here, it says that we want to convert 2 comma pi over 3 from polar to rectangular. And given that we know a couple of formulas now, I can actually do that. Remember that since this is a polar coordinate, this is r comma theta. Rectangular means I want x and y. Since I want x and y, I'm going to be using these two rules right here. So x is r cosine of theta. So 2 cosine of pi over 3, 2 sine of pi over 3. If this was an MCQ, you should probably simplify this. So pi over 3 is going to be 1/2. And then sine of pi over 3 is going to be root 3 over 2. Simplify that some more, and you're going to get 1 comma root 3. So this is going to be your final answer. All right, number 7, we want to convert 1 comma negative 1 from rectangular to polar, where r is greater than 0 and theta is between 0 and 2 pi. Well, if we're converting this from rectangular to polar, I have this being x and I have this being y. Well, polar, remember, means that I need r comma theta. So I need r, which is just going to be x squared plus y squared, but then we're going to take the square root of that. So r is going to be equal to 1 square plus negative 1 square, and that's going to be 1 plus 1, or root 2. So this tells me that my radius is root 2. All right. Now to find theta, they already gave me x and y, so the easiest thing that we're going to do is just find theta using inverse tangent. So we have tangent theta is equal to negative 1 over 1. Tangent theta is equal to negative 1, which means that theta is equal to inverse tangent of negative 1. Now, I want you guys to think about inverse tangent of negative 1 and where that belongs, especially if we have 1, negative 1. If I were to sketch out 1, negative 1, this is going to be in the 4th quadrant. And remember that my domain for inverse tangent is going to be from negative pi over 2 to pi over 2 right here. So whenever I'm thinking about what's going to give me negative 1 right here for inverse tangent, I'm going to think about how pi over 4 gives us root 2 over 2, root 2 over 2, which gives us 1. But since I want a negative 1, this is going to be 7 pi over 4. The problem is, I can't really have 7 pi over 4 because my theta is going to be from 0 to 2 pi. So in this case, my theta is going to be from, my theta is going to be root 2 and then negative pi over 4. Or in this case, root 2 and then 7 pi over 4, since it's asking us for theta to be between 0 and 2 pi. So I'm just using coterminal angles right here. All right, number 8. We want to convert from polar to rectangular, so same method where we are going to have r and theta right here. So we have r, we have theta. To find x, comma y, we are going to use r cosine of theta, so negative 2 cosine of 7 pi over 4. y is going to be negative 2 sine of 7 pi over 4. This is going to give me negative 2, and then thinking about 7 pi over 4, that's going to be in my fourth quadrant right here. So that's going to give me root 2 over 2. And then for y, I'm going to get negative 2, and then I'm going to have negative root 2 over 2. Simplify that, I'm going to get negative root 2, and then I'm going to get positive root 2 as my rectangular coordinate for number 8. Number 9, I want to convert that from rectangular to polar. So what I'm going to do is go ahead and figure out what r is, because I want r comma theta. So in this case, r is going to be the square root of 3 squared plus 3 root 3 squared. That's going to be 9. This right here is going to be 9 times 3, which is 27. So now I have 9 plus 27, which is 36, which means that r is going to give us 6. To find theta, we are going to use inverse tangent. So theta, tangent of theta is equal to 3 root 3 over 3. Tangent theta is going to give us root 3. So theta is going to be inverse tangent of root 3. Now remember that 3 comma 3 root 3 is going to be in the first quadrant right here. So we don't really have to worry about any changing in terms of number 9 right here. We just got to think what's going to give me root 3 for inverse tan. And that right there is going to give us pi over 3, because remember that pi over 3 is 1/2 root 3 over 2. So that means that tangent of pi over 3 will give me root 3. So that means that theta is going to be pi over 3. Combine that, and you're going to get 6 comma pi over 3 as my final answer. All right, 10 is very similar to 6 and 8, and then 11 is going to be similar to what you did at the very beginning of 2, 3, and 4. For 12 through 19, however, these are going to be the more complicated ones, just because we have equations instead of coordinates. We're still going to be using the same method where we have r sine theta, r cosine theta. Cosine theta is equal to x over r, sine of theta is going to be y over r, and all of that good stuff. So for number 12, whenever we are asking for a polar equation for the curve represented by y is equal to 1 plus 3x, this right here is in rectangular. So I want to change this so that it has some sort of r equals or r squared equals. I just need r equals somewhere. We know that y is going to be r sine of theta, and we also know that x is going to be r cosine of theta. I'm trying to solve for r, so I'm going to do r sine of theta minus 3r cosine of theta is equal to 1. I'm going to factor out r, and then I'm going to set that equal to 1, and then I'm going to solve for r. So r, in this case, my rectangular equation, y is equal to 1 plus 3x, can be represented by the polar equation of r is equal to 1 over sine of theta minus 3 cosine of theta. A similar problem. We want to find a polar equation for the curve represented by x squared plus y squared minus 2x is equal to 0. Well, we know that x squared plus y squared is going to be r squared. So that, I'm just going to say that's r squared. We know that x is r cosine of theta is equal to 0. I'm going to go ahead and factor out r since I want to solve for r. I'm going to divide by r, so that just cancels out. And then since I'm going to solve for r, I'm going to get r is equal to 2 cosine of theta. That's my answer. For 16, we want to find a rectangular equation for the curve represented by r is equal to 4 secant theta. All right, so if we have that, we probably want r sine of theta or r cosine of theta. For number 16, I'm going to write secant to be 4 over cosine of theta. I'm going to multiply so that I have r cosine of theta is equal to 4. R cosine of theta is just going to be x. So this right here is x is equal to 4. Right, same thing for number 17 here, where we have r is equal to 5 cosine of theta. Here's the problem about this one. Remember that I want r to be, or I want x and y to be r cosine of theta or r sine of theta. And right now, I really don't have anything. However, what I can do is multiply by r on both sides. That's still going to give me equivalent equations. So I'm going to say r squared is equal to 5r cosine of theta. So anytime you don't have an r, multiply an r so that you get it on both sides. So that you could say that, oh, r cosine of theta, that's just x. R squared, that's x squared plus y squared. And this, just keep like this. 18, we want to find a rectangular equation for the curve represented by r is equal to negative secant theta tangent theta. Once again, what I'm going to do is try to put this into sines and cosines. So I'm going to have r is equal to negative 1 over cosine of theta times sine of theta over cosine of theta. I'm going to multiply by cosine of theta on both sides. So that's going to give me r cosine squared theta is equal to negative sine theta. Now, you might think, okay, I'm going to have r cosine of theta. So you could split this to be r cosine of theta times cosine of theta. Well, the problem is I don't have an r with this. But what I can do, remember, is multiply by r on both sides so that I have equivalent equations. R cosine of theta and r cosine of theta on the left side is just going to be x squared. And then this right here, negative r sine theta, is going to be negative y. So my equation here is going to be x squared is equal to negative y. Same thing with number 19. I want you to pause the video, try it out first before attempting to watch the video. So do that, and then I'll give you the answer. So r is equal to 5 cosine theta over sine of theta. Cosecant of theta is going to be 1 over sine of theta multiplied by sine squared of theta on both sides. That gives you that lovely thing right there. Problem is, once again, I need to multiply by r here and r here. R squared sine squared theta, that's going to be y squared. And then 5 r cosine theta is going to be 5x. All right. In the next video, we are going to talk about graphing polar equations. So that's going to be a lot of fun. And then once we do that, we'll talk about the calculus of polar, which is going to be even more fun.